This video will demonstrate how to use the package symbol wizard to create a footprint. I have taken a sample QFN datasheet to create. I will gather some input before starting the package symbol wizard. In the datasheet of the QFN, we do have recommended land pattern. The dimensions provided in the datasheet are in millimeters. The width of the pad stack is 0.6 millimeters and the height of the pad stack is 0.25 millimeters. The thermal pad dimension is 5.1 millimeters and it is a square. The number of pins per side is 12 and the lead pitch is 0.5 millimeter. The terminal spacing details at all places are 6.8 millimeters. The size of the package is 7.1 millimeters including tolerance. The height of the package is 0.6 millimeters and pin 1 is in the top left corner. Before going for the wizard, we will do some prerequisites for creating the package symbol or the footprint. I had already created the pad stacks and placed them in a common location where we can access the pad stacks. The location of the path is shown in this video here. The pad stacks created and kept are 0p6 by 0p25.pad and sq5p1.pad. After having the prerequisites ready, I start the Allegro PCB designer with an Allegro design. BRD open. The path of the pad stack should be pointed using Setup User Preferences Library Pad Path and add the path as shown in the video for the pads to be used. We are going to need to start a new package symbol wizard to create the footprint. So, we'll do File, New. Since I want to create a footprint using the package symbol wizard, I am going to scroll down here to our drawing types and select package symbol wizard. We want to give that a name, so we'll give a name QFN 50p 700 by 700 by 60 to 48 and select OK. The package symbol wizard gets popped up. The package symbol wizard populates with different package options like DIP or SOIC or PLCC/QFP or PGA/BGA etc. From these available options, we can select PLCC/QFP and select Next to proceed. The wizard takes us to the next window, Package Symbol Wizard, Template. In this form we have two options to select a template. The first option lets us load a Cadence default template. The second option lets us load a custom template. A template is a draw file that has basic information for the package symbol. When creating a custom template, there are certain do's and don'ts that need to be followed. We can create a template that has basic information on colors, text sizes, or documentation for our symbol. We should not add any data to pin, etch, package geometry, package keepin, package keepout, reference designator, route keepin, route keepout, via class, via keepout, and manufacturing will interfere with the symbol generation process. Creating a custom template is not the scope of this video, so we will proceed with loading the default Cadence template to our design. Select the default Cadence supplied template option and select Load Template. You can observe the template is loaded in the design. I will select Next. The package symbol wizards take us to the next form. Here we are having options to add inputs with respect to units, accuracy, and the reference designator prefix. The package symbol wizard, general parameters help us to define the units at two places. In this form, the first field is the location where we can specify the units for defining dimensions in this wizard. The second field is the place where we can set the units for the package or the footprint symbol. If I scroll through the units, I can see the available units are mils, millimeter, micron, inch, and centimeter, and you can change the accuracy of the drawing units. We can change the accuracy from 1 to 4 after the decimal point to all dimensions, except micron where the accuracy can be a max of 2 only after the decimal point. In the datasheet we are going to create, the dimensions are in so it will be easy for us to create the symbol if we maintain the units for both entering and units for creating the package symbols as a millimeter. I had kept the units as millimeters and the accuracy as 4 at both the places where we must define the units. The reference designator prefix provides options U star, C star, R star, and J star. On top of that, if you want any specific text as a reference designator, you can enter the reference designator prefix, which will appear on symbol creation. I am going to leave the reference designator as U star as we must keep U star as the reference designator for the quad flat no lead package we are going to create. I select Next. The package symbol wizard takes me to the next page. Now the package symbol wizard asks for 3 values. The first input the form asks for is the horizontal and vertical pin count. The second input the form asks for is the location of pin 1, and the third input is the lead pitch. For the QFN to be created, the pin count per side is 12 and the total pin count is 48. The 48-pin QFN has an additional thermal pad which must be added manually as we do not have an option to add a thermal pad in the wizard. As per datasheet, the pin 1 of the QFN falls at the top left corner and the basic pitch or the lead pitch for the component is 0.5 millimeter. After adding the values, I select Next. Now the wizard asks for the values terminal column spacing E1, terminal row spacing E2, package width E, and the package length D. Cross-checking the datasheet, I observe that my values for E1 and E2 are 6.8 mm typical and the package's width and length are 7 mm excluding tolerance. Adding these values to the wizard and I select Next. Now the wizard asks us to load the pad stacks to be used in the footprint to be created. We had already created the pad stacks and kept them in the library path, and we had defined the pad paths. In this form, the first field asks for the name of the pad stack to be used as a default pad stack and the second field asks for the name of the pad stack to be used as pin 1. I had already created the pad stack referring to the datasheet and placed the pad stack in my library. More often the first pin in the symbol will be slightly different in shape when compared to other pins. This is made specifically to identify the pin 1. By referring to the datasheet we can see we don't have such requirements for creating the QFN. I browse through the first field and select the pad stack to be loaded 0p6 by 0p25. The same pad stack automatically gets loaded in the second field also. If we have any specific pad stack for pin 1 we can update in this second field. As we do not have any, we will leave it as it is and select Next. Now the wizard asks us to choose the center for the symbol body. It provides us with 2 options. One makes the center of the symbols as body center or makes pin 1 as the location of symbol origin. The wizard also asks whether you want a compiled symbol or not. In the wizard, I select the location of symbol origin as the center of the symbol body, and I ask for a compiled symbol and select Next. Now the wizard pops up with a summary of what are the files that are getting created in our current directory. I select the Finish button. Now the wizard gets closed, and I can see a 48-pin QFN. But I had missed the thermal pad as we do not have any option to add the thermal pad to the wizard. I am going to add the thermal pad manually. I select the Add Pins option, browse through the available pad stack, and select SQ5P1. In the pin hash field update the pin number to 49 and in the command window I place the coordinate X00 and I gave enter. I had added the thermal pad. Selecting Display Show Element command and from the Find option selecting All off and setting Shapes only and selecting Shapes in the PCB window, I can see the class package geometry subclass Place Bound Top and subclass DFA Bound Top are present. Adding a no probe top in the symbol by using Z copy with expanding the shape to 0.254 mm. If I query the lines in the symbol, I can see the package definition, width and length, Gets defined in package geometry assembly underscore top and silkscreen underscore top with 0 line width. I am going to add the package height 0.6 mm in the place underscore bound underscore top. In general edit mode, setting the class to package geometry and subclass to place underscore bound underscore top. Go to edit properties and add package underscore height underscore max to 0.6 mm and give apply. The height property gets added to the footprint. Now we have a 48-pin QFN footprint. You can update this base footprint as per your customer needs or as per your company standards. That concludes the demonstration on how to use the Allegro package symbol wizard to create a 48-pin QFN footprint.